1 meter metal bars are joined to make a 4 by 4 jungle gym with 64 spaces. Huh? Do you see that? These are 1 meter by 1 meter spacing, and this is a metal cage. So you go here and go up there. This looks like just a whole bunch of triangles to you, no? To some students can see this and others can't. Let me make it a little easier for you by showing you where the top is and bottom is and side is, and this may not help some. But before we do anything, we have to see what this looks like. So I made a little animation to show you to help your understanding. So it looks like this. So this is what we're looking at, a cage that is 4 by 4. And now we have to classify the joints here, where they are meeting. If you look at the very edge here, let me show you. Let me move it up. This corner here, how many on this corner, how many are meeting? How many bars are coming there to meet? For here, I have 1, 2, 3 that are coming in to meet here, right? So that's what the problem is classifying as. What did it classify as? Number of metal bars meeting at a point. That's what it is. So what I just showed you, this corner here, there's 3 of them meeting. So you think you got it figured out. And there are 4 at the bottom and 4 on top. So altogether is 8. You know, you can handle it. And they handled it for you. So they told you it's 8. So that one you don't have to do. That's the way it is. Now let's see if we can get some other ones. So now if you go around here, this one, how many are coming there to meet? We got 1, 2, 3, 4 of them. And this is the case here too. 1, 2, 3, 4. 1, 2, 3, 4. So now you think you see a pattern. So let's see what kind of pattern we see. Let's zoom out a little bit, bring it down here. How many of those will have that the 4 of them meeting here? Obviously 1, 2, 3, 4 in this end, and there's 1, 2, 3, 4. Basically, each edge has 3 of those corners, or should we say joints, where 4 bars are coming to meet. So I have so I got 4 edges around here at the bottom, and let me write it down here. I got 4 edges. Each one has 3 of them that are meeting. Then again, here I got those, right? 4 of them are coming to meet, and it's hard to see, but here, the edge that is facing us, and this. So going around, I also have 4 of them, which has 3 of each. See, I got 3, and I got 4 corners. 1, 2, 3, 4 corners. And if I go to the top here, then I have these ones again, so I have 4 times 3. So there are 12 each, and there were 3 of them, right? So I got 36. 36 what? I forgot the terminology of it. I have 46 meeting at a point. Number for how many? It says 36 of them will meet at this location. Here would have this one, right? 4 of them, 1, 2, 3, 4 coming in here. And there are 36 of them. 12 at the bottom, and 12 on the side, and 12 on top. Okay, now how many of them have a 5 metal bars coming in to meet? Where could that happen? It happens on the face here. So let's see if we can see them. If you see, just see one face, then you can see. Let me see if I can bring it down here so that I can. Let me use this one to show you. So this way, you don't have to see all the distracting side shows here. Okay. Now, if I see this top surface here, if I zoom in, let's see. I got how many? Let's count. 1, 2, 3, 4, 5. So this one is such a joint, right? And let's take a look. How many do I have? On top surface, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 of them, and there are 6 faces. So 9 times 6 would be the answer. That's 54, right? So let's see if we can go back and fill in. So what is this? 5 faces, it was 54. I mean 5 metal bars joining. What about this 6 business? In what case would there be 6 metal bars joining? I think you got some ideas already, do you? If you go inside, then that's what you will get. So let me see if I can show you the one. Okay, let's just leave it at that. I want to just show you one of them so that you can easily see. I'm trying to hide all the distractions from you so that you can see one of them. You see this one here? Let me get closer. This one has 6 of them going. You see? I got 1, 2, 3, 4, 5, 6. So this is the joint. So if it's inside, then you got the 6 metal bars coming in to meet you. How many of them are there? It takes some thinking to compute. Do you know already? Okay, now let's move these guys away so that we can see what's in it. Basically, I think I should show you this way. It has to be something that is inside. That is, it has to be deeply embedded so that you can expand to all 6 directions. So, how many of them are there? Let me show you if I can see it better. Here we go. It will be 9 by 9 by 9. Why? I hope you see it. It's 9 that way, and if I bring it this way, might as well move it higher. So it will be 9 this way, right? And then if I rotate, it will be 9 from the top. And need I show you? The 9 from this way. So the core that is made of 9 by 9 by 9, or I should say 3 by 3 by 3, right? So this is the inner cores are, how can I show? Inside ones that is 3 by 3 by 3. That will be the ones that have the 6 connections. So I will have 27 of them. So let's go back to our chart here. So I would have 27 of them. It is kind of daunting that you have to get all that computations just by looking at this. And if it's not even shown like that. It's shown like this. Whoa! How can you get out of all these tangles of squares and parallelograms and triangles? So you got to see the diagram, the object I showed you in your mind, and you got to come up with all these numbers here, and find the sum of numbers of the following chart. So now I have to add all this, right? Can I get lazy in some way? Okay, these two would be 80, 90, right? And these two I got to work. So this, if I add them, I get 35. So if I add them, is 125. Is the answer. Okay, now, but I looked at the answer on your book, and the answer is 117. That means they didn't count us. So here you're supposed to know, find the sum of the numbers in the following chart. So here's a chart for you, and if you add them all, you get it wrong. What they meant was, find the sum of the numbers in the chart that you filled in yourself. So you're supposed to understand that out of this problem and add only these parts, then you would get 117, which is the answer they gave you in the solution book.